I gave an AI a codebase full of security bugs, SQL injection, hard-coded passwords, command injection, the works, and asked it to find them. One AI missed half of them, so I built 6 and made them work like a team. Here's the thing nobody tells you about AI code review. If you ask one model to find all the security bugs, classify them, test the APIs, and write a report, all in one shot, it chokes. It skips things. It runs out of context. It gets vague. It's basically asking one person to be a recon specialist, a pen tester, a threat analyst, and a technical writer, all at the same time, on their first day. So instead, I split the job. 6 agents, 6 jobs. 1 assembly line. This is a command line tool built in Node.js that scans a codebase or a live web page for security vulnerabilities. It's powered by Groq, which is stupidly fast for inference, running an open model called GPT-OSS-20B. No database, no cloud backend, just your terminal, an API key, and 6 agents passing notes to each other through shared memory. By the end, you get 2 files, a full security report and architecture diagrams, automatically generated. Let's walk through the assembly line. Agent 1 is recon. This one just looks around. It reads your code, or fetches a web page with Cheerio, think jQuery but on the server, and figures out where user input comes in, where the app calls external services, and where the authentication logic lives. It's mapping the attack surface before anyone touches a single vulnerability. Agent 2. A is API discovery. Running right alongside Recon's output, this agent hunts specifically for API endpoints, REST routes, GraphQL forms, WebSockets, and catalogs the method, the auth requirements, and the parameters. Basically, here's every door into your app. Agent 2B is vulnerability analysis. Now we take Recon's findings and actually classify them. Is this cross-site scripting, SQL injection, CSRF? The agent rates severity, rates its own confidence, and, this is the part I like, predicts how the risk could escalate if it's left alone. Agent 3A is API testing. This one goes deep on the endpoints from step 2. A. Injection flaws, broken authentication, missing rate limits, bad CORS configuration, and business logic bugs, and tags each one with a CWE ID, so it maps to industry-standard vulnerability categories. Agent 3B is architecture diagrams. While all that's happening, this agent rereads your source code and generates 3 Mermaid.js diagrams: your components, your data flow, and your security layout. Instant visual documentation. And finally, Agent 4, the reporter. This one reads everything. Every finding, every endpoint, every risk score, every diagram, and writes it into one clean report. An executive summary, a findings table, a severity breakdown, and a prioritized fix list. What do you fix first? It tells you. Here's the architecture trick that makes this work. The agents never talk to each other directly. No agent calls another agent. Instead, they all read and write to one shared memory object. Recon writes its findings. Analysis reads those findings, writes its own. Testing reads both. The reporter reads everything. It's dead simple, just 2 functions, write memory and read memory. But it means I can swap out any single agent, improve its prompt, even replace the AI model it uses, without breaking the other 5. That's the whole point of decoupling. Now, important part. This tool does not attack anything. Every single agent's instructions explicitly say, identify the risk, explain it. Do not generate exploit code. When it checks a URL, it only fetches public pages, respects rate limits, and it's not sending malicious payloads anywhere. This is a read and reason tool, not a break things tool. And that distinction matters both legally and ethically. You should only ever point this at code you own or have explicit permission to test. To prove it works, I built a deliberately broken test app, SQL injection through raw string concatenation, cross-site scripting with unescaped user input, a command injection bug, hard-coded API keys sitting right in the source code, even an eval call taking user input directly. A greatest hits of security disasters. I ran the scanner. It caught them, classified them, scored them by severity, and handed me a fix list in about the time it takes to make coffee. There's more I want to add. A feedback loop where the analysis agent can ask recon for more detail. A cost tracker so I know exactly how many tokens each scan burns. Caching so unchanged files skip the AI call entirely. And eventually, a web dashboard to compare scans over time. If you want to see the code, it's linked below. And if you're building anything with multiple AI agents, this pattern, focus jobs plus shared memory, will save you a lot of pain. That's the build. 6 agents, 1 pipeline, 0 exploits. If this was useful, subscribe. I'm building more AI agent tools.